Okay, what I've got here is I'm just going to work with these column B and column C. This is variable data. Let's say we're testing a drug to see if it'll increase red blood count in chemotherapy patients. So this is before the drug is administered. This is after the drug is administered, right? And it's just random order, okay? So first thing I want to do, anytime I have variable data, I want to know the center point and also I'll make this bigger here. I want to know the center point, I want to know the variation. So the way I find the center point is using the average. I'm just going to take column A or B here, close it off. So you can see my average is 15,397. Let's look at the next column, 15,396. So there's not much of a difference here. And I also want to know the variation. The way I do that was a standard deviation. Again, it was a sample, so I'm going to use a sample standard deviation. Type in my first array, close it off. So there's my standard deviation, 18.2627. Second one is 17.0689. Now what I want to do in a t-test, I said, is there a statistical difference between these two groups? In other words, my null hypothesis is there is no difference between these two groups. And the variation I'm seeing is just a result of random variation. So the way I do that is I'll come in here and I'll type in t-test. And it's going to ask me for array 1. That'd be this group here. Okay, it's going to ask for array 2. That'd be this group here. And for the Greenbelt course, I always want to use a two-tailed test. So I'm going to type in a 2 here. Okay, and then this thing here, let's not worry about that, but we're always going to use number 2 here. This homeostatic. Right? And again, I'm not going to get into it, but it comes from this part right here. So I come up and I get a 0.08 or 0.80152. And what that's telling me, this is my alpha. In other words, what's the probability of this just not being random chance? Another way of saying this, there's probably about 80.152% chance that the variation I'm seeing between the two groups is a result of random variation. And since this alpha number is quite high, I failed to reject the null hypothesis. So in other words, I'm saying that these two groups are essentially there's no statistical difference between these two, significant statistically difference. Okay? So that was the first sample. Now let's do it at the same test again, right? Different numbers. I'm going to be working with column H and I. There's the before the drug and after the drug. I'll just take a look at the numbers. They don't look much different, really. So same thing, I want to figure out the center point. And same thing for the second group. Okay, then I want to do the standard deviation again. Look at my variation. This is just a good habit to get into. I always want to know the center point and the variation. Standard deviation and the average. And we know this is a sample, so I'm going to do. You can see there's quite a little bit of difference. But look at this. There's only about a 16-point difference between these two. Not much difference, but is it statistically significant? So I'm going to do my t-test on this. Okay, there's array 1. Array 2. Again, we want the two-tailed test in Greenbelt. So it'll always be 2, 2 at the end. In this case, I came up with 0.0087. In other words, there's less than 1%. So it's 0.87% chance that the variation I'm seeing between these two groups is a result of random variation. This is my alpha number, very low alpha number. My p-value is another way of saying it. So my risk on this is I got probably 1 in 100 chance of getting it wrong. So what I would conclude then is, since the P is low, HO must go. In other words, I'll reject the null hypothesis. So this 15,417 compared to 15,401, that is statistically significant. The odds of that just being random variation is less than 1%. Now in this case, I talked about blood samples. You can do this with almost anything. Anytime you have variable data, is there a variation in lead content in water? I was working with a doctor up in Massachusetts. We're looking at vitamin D in the body and the effects of Roundup on vitamin D. And we did, I won't get into the results, but we did the T-test. Variable data, and you want to know if it's statistically significant. You do that with the T-test. 5%, 0.05 is the magic number. If it's above 0.05, you fail to reject the null hypothesis. If it's less than 0.05, you generally say, okay, it is not random variation. You would reject the null hypothesis. But that's the T-test.